a very exciting moment. It was like, this part of the mission was like a Jules Verne adventure come true. And it was just a remarkable moment.
I could chew your ear off for hours about Enceladus.
I've saved the best for last, and that is the tiny moon Enceladus, an icy moon of Saturn. When we put Cassini in a position to look over the pole in the direction of the sun, which is a geometry which highlights the presence of small particles, this is what we saw.
Well, this is the only picture I'm showing you tonight of Enceladus. This is that picture. They'd already seen some hints of something earlier on. So they found a spot they could get a picture of Enceladus with the sun behind it. So they're silhouetting it. And sure enough, when they did that, they saw these jets of stuff. Since then, they have flown through them. They did all kinds of spectroscopy on them, what have you. They know it's mainly snowflakes, water ice.
When we flew really close, we found that, yes, there was an atmosphere at Enceladus, and the camera found cracks on the surface of Enceladus, and there was water vapor coming out from the surface of Enceladus.
We're flying very close to the surface, just 50 kilometers above the surface of Enceladus. And then we fly through the plume. We just sort of grazed the edge of the plume last time in 2005. This time we're really plunging into the plume.
Here's another view of those icy jets. This is a backlit view similar to what you saw earlier in the Saturn image. You can see the sunlight shining through each of these jets. And we found in the particles that some of those were salty.
We have good compositional information about this plume, and we found that those jets are accompanied by water vapor, but also the particles are salty with a salinity comparable to the Earth's oceans, and that tells you they are salty water droplets that are frozen. Now, Cassini has flown through this plume several times. Actually several. Now it's something like 19 times. There's an instrument on board, there's two in fact, that can pick up material and tell what its composition is.
We'll really be tasting the plume, taking the material from the plume into the instruments on board the spacecraft and analyzing them.
Well, here I have a model of the Cassini spacecraft, and Hunter, maybe you can show us where your instrument is that detected the hydrogen.
Yes, Linda. The INMS instrument, the ion neutral mass spectrometer, is sitting on the fields and particle platform right here, and it directly samples the gas that comes in as we fly through the plume. Let me fly my spacecraft with the INMS pointed in the direction of motion of the spacecraft through the plume material, sampling the gas. This is how it happened when we were making measurements. It was about 8 kilometers above the surface, and this happened in October of 2015.
The geysers on Enceladus are actually quite a lot like Old Faithful geyser or other geysers in Yellowstone National Park that we're familiar with. In fact, the total amount of material coming out of Old Faithful in one of its eruptions is similar to the amount of material that comes out of the geysers on Enceladus.
So we've got this fire extinguisher here today to show us what the plumes really look like. And you can see that they jet out, and they really do jet out. You can see how active Enceladus really is.
This is an interesting view. This is another Enceladus. This is a fountain at Versailles in their gardens there. And this particular Enceladus is a Greek giant, and he had a run-in with his grandniece Athena, and he lost, and so his fate was to be forever buried under Mount Etna. So I think here he's protesting a bit with this giant 82-foot-high geyser of water. Who knew in the 1670s that Enceladus would actually kind of be doing something like this?
Why do you think there's so much more water on Enceladus and so much more organic matter on Titan?
Okay, so Titan is bigger. First of all, if you have a body that's bigger, if it had any volatile material, for example, well, let me just say, it can retain an atmosphere. Enceladus probably is not big enough to retain an atmosphere. So Titan has an atmosphere. It could have been outgassed. I mean, the answer is how, your question is really how it got that way. Enceladus, you just got to remember, Enceladus is tiny. It's really tiny. I guess I forgot to mention, the reason why it is the way it is because it's being flexed by a resonance with its next door neighbor, two satellites over, Dione. So it's got tidal energy that's being forced into it and has been for as long as that resonance has been in play. And that is what has melted the water and created the ocean. And then the organic material, you know, I say let's take it as ground zero. The organics are everywhere. Really, they're everywhere. So, you know, they are there on the ocean, in the ocean of Enceladus. The question is, have they done anything interesting?
People have searched on Mars for water. They've searched on our moon to be able to find water as well. What we didn't expect to find was there was water filling the Saturn system, and there's essentially water everywhere.
Those particles escape Enceladus and go into orbit around Saturn and form the E-rings. So we had found what was forming the E-ring, which had been discovered around Saturn in the 1960s.
We have had the scientists studying these plumes specifically in support of exactly the question of how risky is it to be flying through this part of the plumes. And they've come back consistently and unanimously to say that the particles are very small, micron-sized particles. None of the big particles can get lofted by the plumes to be as high as we're going to be. So the scientists are repeatedly assuring us that environment is just not a threat.
If NASA gave you $1 billion to go to Enceladus and figure out if there are microbes there, do you or other Earthlings know how to do that? Is anybody planning to do that? How would we do that?
Good, that was good. Yes, we are planning to do that. But NASA's not going to give us $1 billion. That's that's the bad news. The good news is we are planning it. There's various ways. Well, first of all, okay, you gave me the opportunity to say, I'm undoubtedly going to get some people upset, but I have to say it because it's the truth. Enceladus is the best place to go. Okay?
Chris, do you think there could be microbes or even shrimp in the ocean on Enceladus?
Why, that would be wonderful, Linda. But we haven't discovered evidence of organisms on Enceladus. But I'm encouraged by the geochemical data, which could allow for this possibility.
Mark?
Why do you say it's not possible to land on Enceladus?
Oh, just
because
because.
on Titan?
No, just money. It's, you know, the bucks. There's no bucks. It's a lot of.
Maybe you can drum up some excitement about Enceladus, a landing on Enceladus.
Well, I'm excited about it. Are you? Well, then, okay, go for it. Get us some money.
Bob Saget here, and this is our $100,000 premiere movie.